Hi guys, OCA here. This video will be quite a unique and comprehensive one. My hopes are high that I will finally complete the long-promised state-of-the-art full manual calibration. I'm going to show you how to measure and calibrate your Dolby Atmos home theater system with up to the full 16 channels capacity. On top of 7.1 floor channels, you can easily map from Windows or Mac OS. You will learn to set up, measure, time align, volume level match, and correct front wide channels left and right, top front channels left and right, top middle channels left and right, and top rear channels left and right. We will repeat the measurements at multiple microphone positions, and I'll show you how to properly align these measurements for one speaker with cross correlation to create the final true response of that speaker. No automation system, including Trino, can do that as far as I know. We will then precisely time align all speakers relative to the center listening position using impulse peaks, which will also include proper time alignment of the subwoofer channel with the rest of the speakers. Finally, we will apply an optimized graphic equalizer correction to each speaker that we measure to optimize their responses to mimic the Harman target curve. You will find the links for every tool and file I refer to in this video in the comment section down below. It can all be done with completely free tools. If you don't even want to cough up around $100 for a calibrated microphone, you can just as well use the calibration microphone that came with your receiver. Your results will still be better than what can be done with an automated calibration system. Let's go very quickly over the default settings your receiver needs to be at before starting measurements. I'll show you for Marantz Denon EQ system, but it's similar with any other brand. Basically, you turn off every sound processing in the amp that will interact with the true response of the speaker. Update the firmware if you haven't done so before. Switch the receiver to the correct input that is connected to your graphics card with HDMI. If you have multiple presets, set one of the presets as the speaker preset so that you can keep the manual calibration in one preset and audyssey calibration or the automated calibration in another. Correctly amp assign your system. Here I'm going to be doing a 9.1 channel system, 5 floor channels including surround left and right, and 4 height speakers on the top and 4 wall lamps. Everything off in Audyssey page, including Audyssey itself. All speakers set to large so that there is no crossover, there is no subwoofer effect in the speaker measurement response. Reset all the speaker distances, so they will be reset to 3.6 meters and some of them set to 3 meters. Step is 0.01, which is not true actually, but I will explain later. Reset all the volume levels of speakers, set to defaults at 0 dB. Auto lip sync off, it causes some delays in the impulse response. Cinema EQ off, loudness management off, low frequency effects off. Subwoofer mode, LFE, low pass filter for low frequency effects, 120 Hz. Graphic equalizer on, speaker selection each, and set to defaults if you have used it before, so it resets. And how to set up your computer and microphone. Connect your Audyssey microphone to the mic input of your PC's motherboard here. Alternatively, you can plug a calibrated USB microphone like mini DSP mic 1 to a USB port on your computer, but then you will need microphone's ASIO drivers. Connect your PC's or Mac's HDMI port to one of the HDMI in ports on your receiver. The graphics card HDMI out goes to receiver's HDMI in. If your Mac doesn't have an HDMI output, use a USB-C or Thunderbolt to HDMI adapter. Configure your PC for multi-channel output. REW has perfect instructions on how to set up multi-channel. The link will be given below. Place the microphone pointing upwards at the central listening position and at ear height, like so. If you're using a calibrated microphone, direct Room EQ Wizard to the 90 degrees vertical calibration file as you are using the microphone pointing up. If you're obsessed with centering the microphone between left and right front channels, you can use this free tool from, it's not a free tool, Accurate, very famous room correction software, one of the best, and the free trial software, quite hard to find this link, but I will be listing it below. You can use the mic alignment tool of the software for 14 days, and it is the most accurate way of placing the microphone in the middle. It gives you instructions about moving it one step to the left or one step to the right, and at this sampling rate, for example, the moment you touch the microphone, this switches to the other side, so it's very accurate. However, it needs ASIO drivers, so Mac users, I'm afraid, will not be able to use that. Okay, now time to open Room EQ Wizard. Say no to that because it's by default Java drivers. I won't be using Java, although it detected the UMIC2 microphone. I'll reset the default settings so we can go over together the required optimal settings in REW before measurements. Preferences, delete preferences and shut down. Yes, and then reopen. Now this is a default REW when you install. Again, no to this UMIC. Don't show this message again. We don't want to donate at this stage. Go to Preferences tab. Now, until recently, you had to download and install ASIO for all software to be able to use multi-channel mapping in REW with Windows. This is a Windows-only program. ASIO stands for Audio Stream Input and Output. You have this option where you can select your multiple outputs, or you can stay on Java. By default, the built-in Java can only map left, right, and left and right channels stereo. But recently, REW has added exclusive Wasapi drivers to Java. You can select this as well. This is able to map all the surround channels. And Wasapi stands for Windows Audio Session API, Application Programming Interface. I prefer ASIO for all because it has the lowest latency. Not that it has any the effect is totally negligible, especially given the fake speaker distance stepping in these receivers. I'll demonstrate what I'm talking about later in the video. So you select ASIO and ASIO for all. Then you open ASIO control panel. This is what comes. It is switched to Realtek audio, which is Windows is now my PC is connected HDMI to my receiver. The way to see these things is go to advanced options here, where you can open the branches of a tree view. Now you can see you have to deselect everything irrelevant and select the relevant things to you. You mic 2 microphone and NVIDIA HDMI driver. I'm not sure which one because also the monitor has HDMI. It's probably this one. Then you click reload, and if you see this white triangle, the play sign next to the correct input and output, means you're done. Here, for example, if I was using the calibration microphone that came with my receiver, I was gonna do this rather than UMic, reload. Voila, Audyssey microphone could just as well be used for measurements, still be sending output signals to receiver. Back to UMic. You have to turn this off and turn this off and reload. Sometimes you need to reload a couple of times, but eventually it will always find the correct drivers. And done with ASIO for all control panel. Now you will see that we have 8 channels here. Channel 1 is front left, channel 2 is front right, channel 3 is center speaker, channel 4 is subwoofer channel, 5 is surround back left, 6 is surround back right, 7 is surround left, and 8 is surround right. I don't have surround back channels at the moment. We're gonna be only using 6 out of these 8. As input, you can select either UMic to 1 or 2. We are not going to do anything in stereo, it doesn't matter. Now it's asking me if the UMic has calibration file. I say yes. We are not going to measure stereo, so 1 calibration file is enough. And you go and direct it to the 90-degree calibration file of your calibrated microphone, which is basically a text file like this. Calibration file is loaded, everything is okay here except for the subwoofer signal. It has to be main speaker test signal because we're going to be measuring a lot of speakers rather than the subwoofer. Default output, let's make it front left channel, and default timing reference output. I usually select center channel because it makes more sense, it's in the central location. We use center channel as the timing reference throughout all the measurements. It's useful to check levels here to see everything is working. Click next. And it's working. Now we go to calibration files tab. Only the pink ones are valid. You don't have to delete those, but just for clarity, I'm deleting it. You don't have a sound card file, calibration file. I'm not using a sound card, but mic calibration file 90 degrees should be here. Comms, we are not using MIDI port. So disable, enable MIDI just for the sake of less processing for REW. House curve, we are not interested. Analysis. Everything stays as is except for loop back delay reference. We have to untick that because we are not using a sound card. Adjust clock with acoustic reference should definitely be ticked, and all these other options be as they were. Equalizer tab. Default equalizer stays generic. Target type full range speaker. Here you have to add a room curve so you don't have to edit every time you open an equalizer window. And keep these two frequencies, low frequency and high frequency, the same. Doesn't matter which one. Let's make them both 500. And as 10 the minimum possible. And here the slopes for both high and low frequencies are the same, and 0.7. You can adjust this according to your taste, but this is a very standard and tested to be most enjoyed by listeners, straight target curve. Drop filters if gain is small, untick that. And in the view tab, I don't like to use tick traces for averages and highlighting, but for the purposes of demonstration in this video, it could be useful. So I will keep them as they are. Maximum measurements. The limit is 199. Make it like 100 if your computer has enough memory, because also the measurements will be quite long. because it's going to ask you to restart Rev at the moment you need to change this and change it, and 30 will not be enough, especially for 16 channel Dolby Atmos measurements. And when you save and restart Rev, all the window frames move to different locations, etc. You don't want that. So better do it now, and we are finished with all the preferences, and restart REW so that it has 100 measurement capacity. And now we can start measuring. One last point, if you're using Java drivers, then you have to set everything to 48 kilohertz in wherever you can hear, 48,000 hertz. Also the microphone, because Rev works at 48,000. Okay, now measurement. Go to measurement window. First change the frequency range from 20 to 20,000 to 0 to 24,000. Because we are measuring at 48,000 sampling rate, and the limit we can measure is half the sampling rate, Nyquist limit. And get rid of this date time, comes up in front of every measurement you take. Timing reference, use acoustic timing reference. Give it a trim level of 1 or 2 dB, by default it's 0. To see the chirp impulse response in the impulse window so that you can measure the distance. You can do it even louder, but it's going to be higher and easier to spot, but it's too disturbing to have the 2 of these chirps in every sweep, 3 dB louder than the rest. Reference output, I select center channel because of its position being very central to the rest of the system. You're free to select any one speaker, but you shouldn't change it throughout the measurements either. So check levels. I'm measuring center by center channel, by the way. Check levels. 72 dB. We have to increase it to 3 dB. What I did was just with the remote control, I just added some volume to my receiver. I added too much, so 3 dB down. 1, 2, 3. Check again. 75. Okay, it doesn't need to be 75. You can perfectly measure at any decibel level. Actually, the higher the better for noise suppression, but I like to listen to my system around these levels, so it's better for the correction. You do the correction for that particular level that you listen to your system, ideally. And the measurement length, you should use 1 million, which is 21.8 seconds long, and it suppresses noise much better than the shorter measurements. Because I will supply you with this 1 million measurement length Dolby Atmos ceiling measurements, which you will have to play. So you'll have to use these ones. I have also 258K measurements, but they are from 20 to 20,000. And 258K is not good enough for proper resolution. It will have to be 1 million. But for the sake of keeping that video short, I will just do the shortest 128K and measure now the center speaker with center as reference. Voila. Let's call this C. Now we go to overlay step, window. Here you see, first you have to actually check which way is the impulse peak. Impulse peak is pointing down. It's longer than the one pointing up. All your speakers should ideally point to the same direction. It can be up or down, but if one is up, the other is down, then you have to check your phase settings. You might need to change the plus and minus of your speaker cables for those speakers which are opposite the direction. This includes subwoofer. The sound will be much better. So this is the center speaker impulse response. This is the peak at exactly 0 milliseconds. This is actually mu seconds, 1 millionth of a second or something. With U, normally this is a millisecond axis. Because it's the acoustic center reference, it will always be at time 0, the peak of center channel. And this is the little chirp that you heard at the beginning of the measurement, which is used to measure the distance of the speaker to the microphone. The peak of that is here. You come on top of it with your mouse cursor and then press Ctrl key on your keyboard, don't release it, and right click the mouse and don't release it, and then move your mouse all the way to the peak of this center channel impulse, or time 0. They are the same thing, as accurate as you can, and release everything, and this will stay on your screen now up until you click somewhere else. The distance is 2.991 meter, or 9 feet 967 inches, or 8.72 milliseconds. And the sound travels in this much time, exactly 3 meters. So according to the speed of sound in REW, which I think by default is 343. I'm not sure. So this is your center channel speaker distance to your microphone. You go ahead and key this in the speaker distance setting of your receiver. You can do this from the setup menu with a remote control, or you can go to the web interface of your receiver. It's very easy to find this IP address from Windows network settings if your receiver is connected to your network. Almost every receiver has this these days, and once you key it in, it comes automatically every time you type 192. So this is the web interface of my receiver, where I can change every setting with a click of a button from my PC. So it's easier for me to continuously change and remeasure, but you can just as well do it from the setup menu of your receiver. So we go to speakers, distances, and center channel by default is at 360. We're gonna change it to 2.99 and set. Once you click set, it is all set. Now if you measure again, the receiver is going to be timing that channel with 3 meters of delay. However, if you're using your remote control of the receiver, then you have to go back with menu key on your remote all the way back until the setup screen disappears. Only then the adjustment is active. Remember that, because you think you changed something, and then because you didn't go back all the way, you keep measuring same thing over and over. So it's important. But on the web interface, you can just click set and it's done. You don't have to go back in the menu like this. Now, with center speaker properly aligned, you can also check with, I think, the iPhone default app now, measure. If your iPhone has LiDAR, it has very accurate distance measurement. So you can try that, or just measure. You have to double check if this is correct. That means you got everything right. I know my center speaker is exactly at 3 meters, so this was correct. It will always be correct, because the first chirp in the sweep is how REW measures the impulse peak. From the impulse peak of the chirp, the time it measures that distance. And the last chirp at the end of the sweep, which is added recently to REW, is to calculate any clock deviation of the system, because REW knows exactly the time between these two chirps very precisely, aligns any delay in your system stemming from the USB microphone or whatnot very accurately. Now this is finished. We can continue measuring starting from front left. You will do these in 1 million length, by the way. Good luck to you. Overlays. Call this front left first. Overlays. And now we have our, these are the magnifications, by the way. There are other ways to magnify the screen, but I'm used to this one. Now the front left channel. Here is the chirp of it, and here is the impulse peak. From the impulse peak of the chirp, the impulse peak of the chirp should be on the same side as the impulse peak of the speaker. So don't start from here, start from here. Press Ctrl, come all the way here. 2.775, so it's 2.78 in Marantz terms. You go and enter 2.78 and set. Now I will remeasure front, center, and front left one more time, just to show you. Let's call this front left aligned. Also the center channel again. Go to overlays. The first two measurements, we don't need that, but the second, front left and center, as you see, they are exactly on top of each other, I would love to say, but not, because of Marantz distance steps inaccuracies. Unfortunately, I spend the most time in time alignment of speakers, because it should normally just finish here, because we entered the correct distances very precisely, but it ended up shifting by 2 centimeters for the front left speaker. Now you have two options here. Front left speaker seems to arrive earlier than the center speaker, okay? So you have to give it a bit more delay. To delay it a little bit more, you have to increase it. Difference seems 2 centimeters, so you add another 2 centimeters, it make it 280, click set and remeasure. Those remeasurements would never have to be done if the receiver had accurate distance stepping, but it doesn't. Go to overlays again. See now, this is axis 0. It jumped here. By just adding 2 centimeters, it jumped from here to here, which is more than 3 centimeters, 3.6 centimeters. So this is the problem. The chip inside is not accurate to 0.01 meter. So it's just trying to round up and try to hopefully get there. They thought that we will never detect these things, but now we can. I think next time they're gonna start putting more expensive chips inside these things. Anyway, now the jump was too much. So you go back 1 centimeter and click set. And in one of these settings, you will be the closest to the 0 area, and you will have to live with that. You will have to leave the adjustment there. You can't make it better than that. Now I'm gonna measure one more time. This is why I'm measuring at 128, so you don't have to wait 22 seconds for every measurement. Sorry, overlays. And look, it came exactly on top of the first one. This was 277 centimeters. No, 78 centimeters. Then I increased it to 280. It came here. I made it 279 and it jumped back to where it was. This is the accuracy of the amplifier. There's nothing we can do about this. Which one is the closest to 0? This one. So we pick this 280 and set it and call it a day. This is our front. So the inaccuracy will be something between here and here for all speakers, which is around 4 centimeters. This is the capacity of the Marantz Denon line receivers. I hope Pioneer or Yamaha or Onkyo are better in this, because you can actually be accurate to the millimeter, but you are limited with the capacity of the receivers settings. And now I can delete this measurement and this, not this, but this measurement, sorry, and this measurement, and keep this as my front left, and the center is always at 0. You will have this problem with every speaker. You can very quickly adjust this setting here for every speaker instantly after just one measurement, but to precisely align, you have to unfortunately increase it 1, decrease it 1, and choose the closest one. It's a bit of work, but it's worth it. When this sort of time aligning is done, unlike the automated systems never do, okay, the Atmos surround effects are so different. The first time you listen to it, you will be at a shock about how well these recordings really are, how well placed every sound to every speaker. Okay, now you have the information to perfectly align every speaker. Let's move on to measuring Atmos channels. Measurement window. Normally playback is from REW. Measure with the test signals generated by REW. And there is the from file option. You click that, and then you have to upload a sweep file here. Let me show you quickly. This wave file is what will tell REW what kind of sweep it should be expecting. It has all the information that it's from 0 to 24,000 with 48,000 sampling rate and 1 million length measurement sweep. So you just upload this here. And now it knows what to expect. You can even click start now. It will wait forever until it hears the chirp. Now, how do you play the correct signal for the correct channel to it? Here comes the magic. You will obviously have a link to all these files in a zip format. This is the reference file we just uploaded, and these are the Atmos channels. This is front, wide, left, and right. This is top, front, left, top, front, right. These are bit perfect files that play exactly the same sweep that Rev will generate. A guy I don't even know the real name of, Todd Song, in one of the forums created these files. I will link my special thanks to him below the video. You play these files with Windows Media Player, does the job. You can use other players too. You don't have to configure Windows to even 7.1 channel here. Like here could be even stereo configuration. As you see, it doesn't matter. You don't have to switch it to Dolby Atmos or anything. What you have to do though, they use the same line with the ASIO drivers. So you have to stop ASIO from taking over the channel before you move ahead. So what you do is go to Preferences, Sound Card, ASIO Control Panel, and stop ASIO from using the HDMI channel. And just reload for safety. Now it's gone. HDMI channel is now free. And now you can again open the measurement window, click start, and you're not in a hurry. You go there and play whichever channel you want to measure. Top, front, left. Playing with Windows Media Player. There is a pause at the beginning. As you see now, I have here my top, front, left channel frequency response, and it is completely accurate in terms of impulse and everything. This requires an adjustment of from its impulse peak to 0, 40 centimeters. You have to decrease the distance of top, front, left from here, coming top, front, left, 40 centimeters to 260, and set. And when you remeasure that, it will be around 0, but then you will have to play again with 1 centimeter each way for some time until it just sits at the back. But even when you do just plain one time entering of distances here, this is still a lot more accurate than Audyssey will ever get. Don't forget that. But the more effort you put on it, the more accurate it's gonna become. So let's call that top, front, left. If you want to keep measuring, for example, again, measure, start, go to your folder, and this time top, front, right. As you see, it started once it heard the chirp. And this is top, front, right. Now I showed you how to do Atmos channel measurements and time align them. Now it's time to take multiple measurement points, multiple microphone points, and cross-correlate, vector average them to get the actual room response in a more larger area, and also get rid of the temporary local peaks and dips so that you correct the right measurement and right response. I will switch back to normal measurement again. The way to do that, go to Preferences, Sound Card, ASIO Control Panel, and again click this and reload, and HDMI is back at ASIO. Now to measure anything else, you have to go back to this and measure as you used to. Now let's have a measurement in a different microphone position. I moved it now around 30 centimeters easily, even more. Okay, and start. I'm measuring front left again. Oh, sorry, this is 1 million length, it's too much. It should be 1 million, but not for this video. Okay, and now I'm gonna go get another measurement at somewhere else on the opposite side. It doesn't need to be. And remeasure front left. Call this one front left 2 and call this one front left 3. You can do this as many times as you want. The more the better, actually. Let's clear everything else and take only front left 2 and front left 3. Fit them to the window. These are the 3 responses, and they are quite different. Okay, if you smooth them like this, for example, but this is gonna smooth everything now. Yeah, I know it's only gonna smooth the ticked ones. As you see, the responses are quite different, especially in this region, for example. So you don't know what to really do for this frequency. It's useful to have multiple measurements, but it's hard to time align them because the microphone is moving. What you can do, be time aligned everything for the central listening position at FL, if you remember, and this is the central position, so everything should be aligned there. The timing is aligned there. The speaker thinks that it is the distance to that point. That is the correct delay the receiver is applying to the signal before it sends it to the speaker. So you have to align everything to this one. In the overlays tab, if you look at the impulse responses, again, clear selections and select FL3, 2, and 1. As you see, the impulse peaks are quite distant from each other. Let me see how much I moved my microphone. This is the original central location, and to the left I have moved it around 15 centimeters. I thought it was 30. And to the right I moved it 13 centimeters. Okay? Now we have to compose one measurement for my left speaker, front left speaker from these 3 measurements, or 20 measurements, how many you wish to do. How do we time align them? You select front left, the original, the one you want to align each measurement to. Here you select it, and then every measurement of the speaker, including itself, FL, FL2 and FL3 are ticked here. You are in all SPL tab. Go to controls and cross correlation align. When you click this, it will align FL2 and FL3 relative to FL. It will not move FL at all. Like you see, FL here is near 0. Not on 0, unfortunately, because of the receiver's steps, but cross correlation align. Click that, and look now what happened. And these impulse peaks didn't need to come onto each other. It's coming because the measurements are nearby. They could have different impulse peaks. You never know how it will align. It cross correlates the whole impulse, this whole thing. Okay? By shifting back and forth the whole impulse response on top of each other, and calculates where it gives the highest correlation with the original reference impulse, this one. When you have close measurements, it's usually the impulse peaks are on top of each other, but it might have a higher correlation somewhere else here, then it will bring it here. So if you're making very distant measurements, you will have instances like that. Don't be worried. Just know that this is perfectly time aligning it. Now that we have the perfectly cross-correlation time-aligned 3 measurements, and they're already selected here without anything else selected, because vector average averages whatever is ticked on all SPL tab. So you click vector average, and this tick line is your actual front left speaker response that you need to correct for. Okay? Not this, although it was close, not this, or not this. If you corrected any one of those, you wouldn't be doing the right thing. This is like far beyond any automated calibration can even come near to. Now we have the actual response of our front left speaker. We don't need the others. And it is time aligned and correctly distant entered in the receiver because it's the same timing as the FL here. So we can even delete FL. FL0 is our new front left speaker response. You will need to do that for every channel, including the Atmos channels. Now, how do we correct this response to the ideal target curve? First, we need to convert this response to what we will actually hear, for which you have to apply frequency-dependent windowing to this response so that you get rid of the effect of, because it's psychoacoustic smoothed now, you don't see it, but in fact it's like that. Okay, and you have to get rid of these reflections. So you add a frequency-dependent windowing. 15 is fine for average sized rooms with normal furniture. You could get in more detail and higher, but it will not be. It's the best compromise, 15. Ideally, it should be left and right window with different sizes, etc. But REW cannot do that. There is one thing REW cannot do. Accurate can do it, but it's paid software. Anyway, apply this window to this. And before you apply this window, just to show you, let's make a copy of that measurement. Measurement actions, response copy, and just apply windowing 15 with cycle windowing to the copy. Something like that. Look, the response is different in the high frequencies. Here, it's only rounding the peaks and dips when you frequency dependent window, but around here there are differences, and the differences are quite large. It's almost 4 dB. When you don't apply frequency dependent windowing, like Dirac and Audyssey does, you might be measuring 4 dB wrong in these frequencies, very audible frequencies and 4 dB. That's why we need to frequency dependent windowing. That cannot be done in automated calibration in any of them. I doubt Trino does it. I haven't used. So apply frequency dependent windowing to the original left speaker. Done. And also apply a smoothing that will, we're not going to be hearing these dips and these peaks with this much variation. Like the deepest dip and the highest peak in this measurement is around 21 dB. Every 6 dB is half the volume. So imagine this is like almost, if you're hearing this bump here, then you should be hearing nothing at about 280 Hertz. So this is not how our brain perceives this frequency response. The way it perceives it, because the perception is different in different frequency bands, like we are most sensitive to 1000 Hertz, for example. We can detect volume differences in 1000 Hertz better than any other frequency, etc. That's why Audyssey calibrates SPL at 1000 Hertz for every measurement, but unfortunately this doesn't take care of the dips and peaks that you might have in 1000 Hertz. Anyway, you use psychoacoustic smoothing for that, which also no automatic calibration has, which smooths the different frequencies differently. It applies different smoothing at different frequency points according to how our brain will perceive those differences. When you do that, apply, the response becomes exactly as you will be hearing it. Now you have to correct these variations because you can hear these variations. So this is the perfect measurement to be corrected, the way your brain will perceive it. Then we go to EQ window. And this is the target curve with a flat 75 dB response here, 75. But we, if you remember, initially set up a target curve. We add this room curve by ticking this box here, and it got just the slope that our perception will be okay with. And see, my speaker is not that bad without any correction because it's perfectly placed and it's a good speaker. Then you have to let REW calculate the target level from response. Click that and just move the little. Maybe because the response doesn't exactly replicate the target curve. It's like somewhere around here, 21 Hertz, and the roll-off slope is really 24. So you keep it there, click this one more time. Usually this will never change the target level that's calculated by REW, but you know that the now target level of this speaker response is 74.1 dB. This is also the sound pressure level of this speaker. So if you want to equalize every speaker to each other, you may use 74.1. Generate measurement from target shape just to see on SPL screen a target curve like that. So now we have it like a measurement is. For convenience, go back to EQ. Now how do we equalize that with our graphic equalizer filters? Yamaha owners are lucky because they have parametric equalizers. So you can just, for Yamaha, match response to target from 20 to 20,000, let's say. It can boost 6 dB, I think, maximum. And fitness target 1 dB, so as fit as possible. You have to select these two and match response to target. That's fine. This warning, you can just click OK. REW is doing its magic. And coming up, let's get rid of the filters. And this is the predicted. It applied 17 bands of equalizer, 20 bands of equalizers, okay, which I don't think Yamaha has, but it has something like 9, enough. But what is good is that it almost perfectly replicated the target curve. I mean the difference. And when you apply these filters in graphic equalizer, and when you remeasure the same speaker, the response you will see on the screen will be almost exactly the same as this one. Not even half a dB difference. I'm telling you from experience. So you really perfectly match the target curve. However, the parametric equalizer, that where we are free to choose any frequency that we want and change it as much as we want in terms of decibel and apply a bandwidth factor as we wish, is a luxury only Yamaha has. For Denon and Marantz people, we don't have that. We delete these filters now. Okay, now for Marantz and Denon filters. They are peaking filters, PK, and the first frequency band that you can calibrate is 63 Hertz. The Q factor is square root of 2, which is 1.414. And the second frequency band, again PK, is double that, so it's 125 Hertz. And the Q factor is the same, 1.414. Goes on like that all the way to 16,000. I already entered them before. I just go and upload EQ settings from the files. You will have a link to that file as well, so don't worry. But it's very easy to enter them anyway. Once you enter them, you have to save them so that you don't have to do it for every speaker again. Now we have the complete set of equalizers that we have in our receiver, but unlike the parametric equalizer, in this one we can only change the gain level. So we can't do match response to target. Individual max boost is 6. I think in Pioneer it's 12 or Onkyo. I don't remember, but I gave this information in a previous video for why you should manually calibrate your system. You can go and check there. What we do is optimize gains. We just click that once. Voila. Look, the predicted response will be this after applying. It only changed the gains. Frequencies are kept the same. Q factors are kept the same. And it managed still to correct this to this. Not bad. And it doesn't correct for the dips, because behind the scenes it knows that this should not be corrected. It's gonna ruin the sound, and you cannot even correct it no matter how much boost you apply to it. Automated systems have no such information. It checks for the excess phase, dips and peaks behind the scenes, so it doesn't touch where it shouldn't touch. It's quite a decent correction, and when you apply this correction, now let's go and apply it to the receiver. We go to audio, graphic equalizer. Okay, we have another relatively smaller limitation here. At 63, it tells us to apply a gain of minus 9.2. Unfortunately, we have only 0.5 and its multiples. We can do the closest rounding, which is minus 9 for 63. And apply to 125 Hertz, minus 4 dB. Minus 0.2 dB to 250 Hertz. We don't have that accuracy, so it stays, because the next step is 0.5. 0 is closer to 0.2, so we leave it at that. For 500 Hertz, we apply plus 0.8, which is plus 1. 1000 Hertz minus 1.7, which is minus 1.5. Minus 0.6, which is minus 0.5. Plus 1, plus 1. Minus 2.3 for 8000 Hertz, minus 2.5. And minus 8.8, minus 9 for 16,000. Set. And when you go measure this speaker now, you will get exactly the same response as this one, without any difference, hardly half a dB. Obviously, if I measure now, it's not going to give me this response, because this response was an average response that we averaged all around the measurement point. If I bring the microphone back to the original point and apply these filters to that curve, it will become exactly like what it shows us here. But for the sake of uniform bass outside the center area, we compromised. We didn't want to correct for, we could correct for the original front left measurement only, and it would be perfect at just that point. But if you move your head a little bit to the left, or if you're watching two people the same movie, you wouldn't be hearing a perfect response. So here we did the best that can be done for a larger area. But if you're watching movies on your own all the time from a certain place, then feel free to make only single point measurements and do the corrections on just particular measurement only. It's less work, and it will be better corrected at that point, but it will not be any good around you. So this is the correction now finished. One thing to remember, sometimes when you open graphic equalizer, you don't see your speakers here. It depends on the signal that you send to the amplifier through HDMI. The moment you send an Atmos signal from REW, like, just let me demonstrate this. No easy task, but you go to preferences. Again, take control from ACO or HDMI. I'm just trying to send an Atmos signal to the amplifier from a Windows environment. When you just play the sweep now, forward front left, top front left. See, top front left is here. Now the final correction step is volume alignment. You have two choices here. One is align volumes with pink noise, which is a very good measure of how much sound pressure the speaker is producing, because pink noise is a sound in every frequency. They have to give back control to ASIO again. Okay. And if you remember, before you measure, when you check levels, back to from file for left speaker, front left, check levels, 75. So you know that this is 75 dB. You have to wait for SPL alignment, volume alignment, until you finish with the graphic equalizer, because in the graphic equalizer you might be boosting or dimming the sound a little bit. It can vary 3-4 dB sometimes, depending on the speaker's correction. Correct every speaker first, put them into the amplifier, which I accidentally closed, I guess. And then after you put all the corrections in graphic equalizer here for every speaker, go to speaker levels and measure each speaker one by one. This is 75 dB front left, keep it as a reference at 0 dB. And for every other speaker, like speaker 2, front right, no, not measurement, sorry, check levels. This is quite fast. So this is 76 dB. What you do is decrease front right by 1 dB and set. And if you check now, 75. The limitation here is that this also goes with half a dB steps, but the difference from distance measurements is that this is accurate. This does what it says. This is one way, and it adjusts the sound pressure level for every frequency throughout the frequency band. So you, in a way, really adjust the volume levels of every speaker. There is another way to measure it. Imagine, let's apply the same corrections to everyone. Apply frequency dependent windowing to everything, keeping reference time, and whatever smoothing we did, apply psychoacoustics smoothing, apply all. Okay, let's imagine now we have 4 speakers here, but it could be 16. Okay, to align the SPL of these measurements, there is a tool, align SPL here, and it lets you align the measurements at a certain frequency range and at a certain level. If you want, you can align all of them to 75 dB, or you use their average measurements and maybe it will decide that they are going to be averaging at 70 dB, you don't know. But you can change where it aligns for. You can pick 1000 Hertz as your center frequency, for example, and you can align 2 octaves around 1000 Hertz, which is 1 octave to left and 1 octave to right. Meaning every octave you divide the frequency by 2 or multiply by 2. So when you select this one, it will align all these speakers from 1000 Hertz, 1 octave this side to 500, and 1 octave that way to 2000. Between 2000 and 500 Hertz, this area, it will equalize their volume levels. Or you can select 4 octaves and then from 1000 divide by to 500, divide by to 250, multiply 1000 twice, 2000, 4000. So from 250 to 4000, it will align the volume levels. This is another way. In practice, if I click this now, it is going to do the alignment, but we are not going to see how much change it applied to which speaker. So you go and make copies of every speaker measurement, response copy, TFL response copy, TFR response copy, and FLO response copy. Now that you have these copies, you unselect everything and select the copies, C copy, TFL copy, TFR copy, and FLO copy, and align SPL as you wish. When you select 0 here at 1000 Hertz, you're gonna make the alignment that Audyssey is doing, by the way. Let's say 2 and align. See? It just aligned it in this range from 500 Hertz to 2000 Hertz. Here, it make the perfect arithmetic average and equalized all of them to each other, regardless of what is happening in this area. This is useful because, for example, if you want to align for vocals, like all the human speech should come at the same level from every speaker in your system, then like the most baritone male voice is around 60 Hertz and the highest pitch soprano is around 1000, but screaming can go over to 3000. Let's say if you align them in this range from 60 to 3000, you will have the vocals equal in every speaker, which means you get the middle point of this somewhere around 400 Hertz and then align by 2 octaves going from 60 to whatever. You can calculate that. So the way to do that is go to 400 Hertz as center and align 2 octaves. And press OK. And look, now it aligned for this part. Change it a little bit. After it did this alignment, you clear selections and select center and center copy and go to measurement actions, and from here SPL offset to center, you start checking until they come on top of each other. Look, this is too much, but this. So minus 1.5 dB, you have to dim down center speaker for alignment for the rest of the system. You go there and put minus 1.5 to center speaker and set. The limitation here is for C, we were lucky, it was at exactly 1.5, but let's see, untick CNC copy, tick TFL and TFL copy, pick TFL, and now to bring TFL to where it has to be for alignment, you need to apply 3.2 dB plus this time. You go to speaker alignment and TFL unfortunately can only be either 3 or 3.5. So you compromise and select 3. This is the way. Or from check levels in measurement. Now the only part I skipped was aligning the subwoofer. I know many of you are waiting for that. Let's take a subwoofer measurement, which is channel 4. Again with acoustic timing reference kept as center channel. Okay, this is gonna be long, so I'm just shortening it. And here, this is how you adjust subwoofer level. It's 66 dB. So subwoofer has to be increased by 9 dB. However, once you increase by 9 dB and then you set into the amplifier, the Marantz, when it plays subwoofer on its own, adds at minus 10 dB offset when it plays subwoofer with the rest of the speakers. So when it shows you 9 dB up here, in fact, you have to dim it down 1 dB to equalize. You will see that on the screen very easily. It's not a big deal, but there is a 10 dB lost somewhere that you have to take care of. But because it's 10 dB, you can never miss that. You will always figure it out very quickly. Now let's measure the sub. See, it's louder now than the rest of the system. But in fact, it's 66 dB because when it plays it together, it's going to play it somewhere here. So you have to actually increase it a little bit. Anyway, this is not the response we are after. Look at my subwoofer's response, by the way, how flat it is, because I'm using mini DSP and they're properly aligned, as I showed in another video. Impulse tap. The problem with subwoofer response is not easy to read. Let's untick everything. And the subwoofer, as you see, it's just a flat line. Oops, we have to put something else. Now refit the data. One thing you can do is plot, okay, actually the subwoofer is here, look. A very weak, tiny impulse response. You can plot it normalized, then it will have some shape. So the subwoofer impulse response is weird. That's why it's hard to align the impulse peaks. But not impossible. You have to choose the highest peak of the subwoofer impulse, which is here, this one. This is our subwoofer's peak, and this is the impulse peak of the center speaker, which is at time 0. So this is 4.6 meters, 13.45 milliseconds delay. The subwoofer signal impulse is arriving 4.6 meters earlier than it should be. What you do is go to speakers, distances, and change subwoofer distance by 4.6 meters, which makes it 8.2, I guess. Set. But the deviations in this system with the subwoofer are even larger, so you have to give it more tries. Now let's remeasure. And to see the impulse peak better, actually, you have to use a lower frequency here. Let's use 120. Then it's going to be easier to spot. I use multiple monitors normally when I'm not recording my screen. And this overlays graph is always open somewhere. We don't need EQ filters anymore. I'll now look the subwoofer response. It was here, and now it's here. The impulse peak, let's get rid of that one, is almost at 0. Look, this is 0, but it overshot it a little bit. 66 centimeters. It's huge for a speaker, but for subwoofer it's like that. So you take it down 66 centimeters, which is something like 760. Okay, if you want the exact, okay, 760. I know I don't enter the exact figure because it's never gonna sit right on 0 because of the certain bugs of the stepping system. Now another measurement. Voila. As you see now, the peak is exactly at center, right on top of the center channel as well. So this kind of time alignment, the subwoofer will perfectly be in harmony with the rest of the system. The bass will be very sharp and quick. However, the impulse peak is pointing upwards. I need to change the poles of my subwoofer. It should be pointing down as the rest of the system. That doesn't change the frequency response. It only reverses the impulse. So that was it for today. I think we are past 1 hour already, and I hope you enjoy the results after this. Thank you and goodbye.